Hi, I'm class 112 as of Primary 6 from YUMIN Primary School. In this lesson, we'll go on with ordinary differential equations. In ordinary differential equations, we'll use different methods for these questions. And we'll also learn how can we use a combination of different methods and when can we use them. And we'll learn all of these through different examples. And we'll be learning more than 80 of these methods. Okay, so let's take a look at what we have over here. So this is y prime minus y equals cosine x minus sine x. Okay, first thing that we have learned, separable differential equations. When we first look at this, is this separable? This y prime, it is dy dx. But here you have a y here. If you move this one to the other side, but then the x and y will be together. So right now at first here, it's not separable. But is this homogeneous? Well, you don't divide it, so it's also not the homogeneous differential equations. So in recent lessons, we have learned one thing, the IF. What is IF? The integrating factor. Now what is it like? So I'll write it down here. dy dx. So you can say that this part is plus, this px is a function of x. Okay, then you have to times y. Then this is equal to qx, another function of x. Or you can also don't write this over dx. Another form you can write it is like this. You just times dx on both sides. Okay, can we try to make this into this form? Okay. But actually, this is already in this form. So y, yeah, here's matched. How about this negative? Well, px is just -1, so it's fine. Then this other side, they're all functions of x. So yeah, it's also can. Next, what is this IF? Okay, so the IF is e to the power of, you have to integrate px with respect to x. In this case, our px is a -1. So negative, you can just take it outside of that integration. Then it's like this. So what you'll get is e to the power of -x. So this is our IF. Now we times it on both sides. But at this part, when we times it on both sides, we can also, well, times dx on both sides at the same time. So it becomes like this. But this part, can we sort of change it? Because here you have with respect to y, here you have with respect to x. How about both of them at once? So one part is with respect to y, another part is with respect to x. And here is this e to the power of -x. So I think we could use that method of total differentiation. So firstly, this e to the power of -x, it has to be there, otherwise this will not be here. Then when you differentiate with respect to y, it's a 1, so there's definitely a y. How about the second part? We can check. This first part, because it's with respect to x, so one of these x in the power comes down. Yep, that match. Then the other part is in front. And this y is left untouched. Okay, how about this part? Well, at this part, because after that we'll need to integrate. So when we integrate, so it's integrating on both sides, we can put this e to the power of negative x behind. And here's a negative. Then this part, we need to take it out and solve it separately. Okay, let me just tell you what method are we using here. It is integral by parts. So this is using integral by parts. So we can find out the first part. Okay, so there's no boundary, it is indefinite integration. So there is an arbitrary constant. Well, we can put that at last. Okay, in this case, this is our first arbitrary constant, C. In front here, leave it the same. Then behind here, we can differentiate this part and integrate this e to the power negative x. So that it's just like these two changing place again. But beware of this, e to the power of negative x. When it goes in, you have a negative. But this part, cosine, you differentiate, you have a negative sign. Sine, you differentiate, it's just a cosine. So here, when you differentiate, you have another negative. So it's still positive. So this part is a sine, this part is a cosine. Then inside here is d e to the power of negative x. Then this arbitrary constants. Front part is still the same. Now this part, again, we use integral by parts. Then how about the other part? Well, with these two change place again. But be careful, since here is a plus, here is a minus. Then here, the arbitrary constant changes, since you have done the second time of integral by parts. These two parts still the same. But right now here, we'll only take this part out. So let's check what happens. We only take this part out. Sine becomes cosine. Cosine becomes negative sine. Did you notice what happens? Okay, compare it with this part. Did you find a similarity? Oh, well, yes. It is actually at this part, it's the same. But except that this part, I've already put this e to the power negative x inside. So that's why there's this negative. But you just take it as, because here, I never put it inside. So you just take it as I didn't put it inside. So that means it's just like solving algebraic equations. Just move this part to the other side. Then that means here you have 2 times of this. So you need both sides divided by 2. But wait, can we simplify something? In this part, since we have sine, cosine, sine, cosine, we want to try to make it as simple as possible. Well, one thing I noticed here, negative cosine, positive cosine. So this cosine part cancels out. Sine, negative, negative is a positive. So these two combine 2 times. To halve it again is still 1 times. Then this changes again. Okay, so right now we can put it inside here. This part is easy. But we can at the same time combine these 2 arbitrary constants. But because this part is solving, this part is our actual solving method. So we just write it as the first arbitrary constant here. What do you notice on both sides? You have this e to the power of negative x. Well, here you can also write it as C4. So here is e to the power of negative x. Here is also e to the power of negative x. So we get times e to the power of x on both sides. So that, okay, let me write it out. Well, actually at this part, we could straight away change it to this. So this 4 is not needed. And this is actually our answer. Since here it says y is a function of x, and here is already in the form that y is a function of x. So we don't need to continue anymore. So this integrating factor is a very useful method. But you need to see what type of question you're using it. For this type, it's very useful. It's very simple, but except that you have to be aware of your calculations. Okay, so for this time, I think I can end it here. Okay, so nothing else that I want to say. It's just you have to be careful of what's your integrating factor and what's your form of this equation. You have to be really careful of that. So you just need to be very careful about these questions, the solving process, then it'll just be very simple. And most importantly is to understand this. So this lesson, I'll end it here. So we'll see you in the next lesson, and thank you for your watching.